Alright, time for another DraftScience video presentation. Alright, so comments, maybe just the background. Just get this, you know, I don't know. It shouldn't be that complicated, but, everything I guess is, everything can be, cut down into the tiniest bits of the universe, and so everything is technically very complicated in that it has lots of pieces in it. That's an annoying reflection, I must say. I have to get rid of that eventually, someday. I guess we could just do it this way. Get rid of it that way. Alright. Sorry. Unnecessary technical detail. Yeah, well, whatever. Anyway, alright, so 2 points. We should all be able to agree now on, this is where the action is really happening, is, on the surfaces. And everybody's math says so. And the simple thing is happening. We're just saying here's a point in space, there's going to be a vector from this point and a vector from this point that'll hit that piece of space. Now, technically, we're going to try to view this on this flat screen, and it really shouldn't matter in some respects because we should be able to say that these point, no matter where I put it in space here on this line, ends up being the same. So if I go up higher, if I make this line longer, I make this line longer, and it shouldn't make much difference. Now, Professor Lewin would say all of these lines are on parabolas, so that would look something like this. They're all curved lines, something like that. I don't know, like a bush, a tree. Anyway, but who cares? Okay, let's forget about that part because it gets too complicated already. So let's keep it really, really simple. So I'm arguing that the simplest way to look at it mathematically, alright, is just to take your 2 points, and all you're doing is making a triangle to a location, and the key to understanding it would be to keep one size standard. So you can't do the standard from here, you can't do the standard from here. Let's just pick one spot, and that's the standard length. So the L distance is one length, L. And so now you can make triangles anywhere as long as you keep this distance L the same. And so then you could argue that's not an ellipse, it's just a perfect circle for this side. That's not very perfect, but it'll do for the sake of the argument. And so the only thing we're doing is we're making triangles from these different locations and saying what's the separation and whether they're on and off. And so the triangle goes like this, so this becomes your unknown. Alright, and this is another known. So you know your L, you know your D, alright, and you can just say what this angle is here. So you can just say 1 degree or 0.5 degrees or whatever degrees you make there. And so then you can just do some kind of simple math. I would argue the math to do is the simplest. So this would just be side angle side. And the trick is, though, then you got to do a cosine. So, so it's best suited for a calculator or a computer to do it and just figure out all these locations, and just by increasing the degrees. So just go with like 0.25 of a degree, the smallest increments, the highest, you can make the resolution as high as you want. And we really should be able to just do this simple, so the calculation would be kind of simple because you're just doing, we'll call that L just for the fun of it. Okay, so it would just be L squared times D squared. Okay, and then that's times 2. Whoops. Yeah, I think it's times 2. And then it's D again and L again. And what else? Oh, and then the cosine of the angle. Okay, and that gives you the answer for the unknown. Okay, the hypotenuse. And so then you just compare that length to this length, and if it's a wavelength, a full wavelength, then you know it's an on, and if it's less, then it's an off. And you could just do it where you just say it's a complete off, you know, would just be a dark spot, and then a complete on would be the lightest spot, and you just gradually work up to the intensity, and then we should get a nice, you know, nice curve line of gradually getting lighter and darker, and see how that also compares to the actual pattern. Because the actual pattern does do this thing. You know, sometimes the bars look incredibly on-off, and then sometimes they can look very blended. You know, just kind of depends on, well, I'm not doing the blend very well. It's brighter in the center, less and less and less. Brighter in the center, and less and less and less. I guess I should do it this way. But that might have more to do with it having an oval shape versus having a square shape. So those are all, I mean, it's just, it really is tragic that this isn't, all this analysis isn't already done. So anyway, I'd say to the mesocosmos guy, whatever, that this is the formula, okay, that I would like used. I think it's right. Well, you should know. I mean, you should know all that side angle side stuff. So in case I made a mistake somewhere in here, I don't think there's any pluses. I think it's, this is, might be plus here. Might be. Anyway. You know, I don't remember any of this. I'm up to fucking mathematics. Anyway, so that's the simple concept. So just do side, angle, side for all the angles, and you should get all the answers, and shouldn't be complicated. See, no one should be disagreeing about this part of it. I mean, this is all there is. There's just this point, and you're just drawing lines to them and just saying how much longer is this line. So we should all agree that it would be stupid to draw the same triangle from two different points. Okay, I mean, if I take the other point and attempt to say this is the L distance, then this line is going to be completely, you know, it's not going to work. So there has to be one center that you're doing it from, and you might as well not create an artificial one. You might as well just use this as the center. Might as well not create ellipses, because that's just going to give you the wrong answer too. It's just these 2 points, and this is your receiving point, and everybody should agree on the 3 points. So there shouldn't be any complexity here besides the fact that people are using different angles, okay, to decide which, you know, to decide this length. And I just think it's easier to do this angle, because that's the only one that matters, really. It's not the only one that matters. Just makes side angle side work, that's for sure. So I guess that's why I'd say I have a preference for it, because the simplest formula solves for it. Simple as long as you have some way of getting the cosine of the angle, simply. I don't know how to calculate cosines, so yeah, that could be really complicated. Anyway, yeah, so that's all I got to say about that, I think. So, to the people doing these simulations, this is the formula I think I'm for. Anyway, so I don't know what you're doing. Yeah, so that's part of the problem, I guess, is I don't know exactly what math he's applying to the finished product. So anyway, I guess I'll just read his comment and see where there's need for opining. Can't read it if it's gone. Oh, he added some more. Cool. Probably. He seemed done with this comment, and then he added some more. It's a little bit okay. So he has his math, so that's cool. All right, right. I was about to do the ellipse, so no ellipses. The ellipse is compounding, and that's not the reality. The 2 points aren't, there's no ellipse in the fact that you have 2 sources and you have 1 receiving point, and so there's no ellipse from its perspective. Okay. 2 circle version 2, but the Gio Cabrera. So, another guy's gotten, said I should learn how to use this thing. I don't really want to learn how to use any software. I just, so much to do and so little time to do it, and I just don't know if I want to learn how to use. I don't think that I'm going to be needing a whole bunch of math, frankly, just because the gravity theory doesn't have almost any in it. Okay, and the kinetic energy theory is really just an argument about evidence, and it's really not an argument about math, because I don't think there is any math to justify it. The math, I've already gone over it, frankly, and just pointed out how their derivative of Newton's equation is complete horseshit. Alright, anyway. And then we have this math, which doesn't seem like it should be that challenging. I mean, it's just a triangle, right? We all should agree on the triangle. Now we're just saying, what does this triangle do? And it can only produce a certain... The result shouldn't be in dispute, frankly. We should all be saying, yes, that spot is an on, or that spot is an off. It really shouldn't be debatable, because we should be drawing the same triangle. Who's drawing a different triangle? I mean, I'm just saying, theoretically, it shouldn't be any. So yes, their theory where it's 2 parallel lines, they're doing a guesstimate about, they're predicting what a wavelength of difference would look like. So I guess they're not really doing the right triangle, because they're dissecting 2 parallel lines to figure out what a wavelength of difference would look like. But they're not predicting the location then, in my opinion. This is the only way to get the location. I mean, there's no other way to get the right location than to to understand it's 2 lines and they go to 1 point. So the only way to get this location is to draw those, to understand those 2 lines and mathematically understand those are the 2 lines you're comparing. You're not comparing any other 2 lines. Those are the 2 lines you're comparing. There's no other way to understand that there's any other lines. Those are the only 2 lines there are to any point. Alright. So anyway, so I'll put a new DraftScience method on another document, and that's fine. I'm really grateful, but I really don't know what math you're doing, so I'm not sure it's exactly still what I'm saying. But anyway, I guess that is going to be the 3rd distinct method then. It looks like the double slit, the double center node. It looks like the double center node with prediction comes distinct from path length difference and theta methods. I don't know exactly what, I assume the geometry has not been handled that way in any contemporary books. So I'm not sure exactly what he's saying, but clearly, I would argue that clearly there is no assumption. All the center stuff is dead. Once you establish that that you're going to do all your calculating using a standard L distance, you have to use it for the same line. So it has to be the same source. You can't switch the L to this source and switch it back to this source and switch it back to this source, or then you're doing that ellipse thing. So the reality is you have to have one L, and you have to have it from one source, and then you get rid of all of those problems. And the fact is the one source is a different, obviously this point is coming from a different location. I mean, a different arc, if you were to make it, if this was the L. And for the back side, you're just saying how much shorter does the line get, right? So you're looking for wavelengths longer going this way and wavelengths shorter going this way. But you have to use one circle. I mean, you have to use one source tied to the L. And then you'll get, in my opinion, rational results for that arc. If you want to do a different arc, well then yes, make all of the L's this one. And you'll get a different arc in different locations. Okay. But there's no center. The the sources start here at 0 degrees. This one is 0 degrees here. At 0 degrees, they're in different locations. So everything in here is dead. Doesn't mean anything because it's inside of a tiny amount of space. Alright, then people just need to do experiments and compare the results with the math. Yes, that's what we're heading for. Now the next step is going to be trying to find some reliable data regarding people actually doing the measurements of the experiment, like actually getting precise slit widths and then a precise distance to a target location and precise measurements of the nodes. And physics won't produce that easily. Anyway, alright, DraftScience method calculating the location. So this is the simulation he produced. And it's all fine, but yeah, see, this math is who knows what, square root of this, that, blah, blah, blah. I mean, this, I understand squaring the result, but this result isn't in the same form, and this certainly isn't the same equation I used, so that's my only critique. He did the color separation here, which is nice to add, and it looks correct enough, but that's all I can say. I can't say much more than that. And then the other version is kind of interesting because it does it from the two separate locations, and you can see where they overlap is kind of interesting. So you're getting another pattern in the pattern, which is also interesting. But I don't know if it's exactly, you know, it's not, I don't know if it's telling me what I need to know, and such. So at least it has no center here, which is good. So there's no, let's not mess with no centers. And so the idea is the first two nodes would be created, you know, close to each other, and then they would get further apart. Now there's not, the nodes are getting bigger, but the separations aren't getting bigger, which is kind of strange. So I don't know what to say about that. But this is the basic idea. You're just doing a triangle, and who cares about these extra, see, I wouldn't bother comparing the angles. I just compare the one angle, and that'll tell you the length of the hypotenuse, and then just compare the two lengths of line. So it all depends on how you do the math, and so so we're still a little bit, yeah, who knows. I don't know whether we're arguing anything meaningful. If everybody can concede that there's no other way to do it than to draw two lines to the point and understand, I mean, whether you're doing it mathematically or you're doing it on a physical board, there's no way to understand how the interference takes place than to understand it's because of the length of these two lines from the points, sources. And the wavelength difference is just, we're just trying to find a way to calculate this wavelength difference, the difference in this line. How much does the hypotenuse change as you change the angle? All right, anyway, Cx equals function, that is the formula comparative to the L divided by D, might be possible to reduce to a more simple one. Yeah, well, I don't know how much, well, I don't know. I don't, you know, it's all of this, like I said, the math is a little bit complicated. Click phase end, start from 0, slider to move the arrow to render the phase gradient coloring. The red pillar on the right of the simulation represents the light beam coming from the slit. It was a good point in the video to mention that the central impediment shouldn't have this beam. Right, so now he's talking about, the fact is that the two slits, I mean the single slit and the single impediment are the same experiment. Right, you're just taking a slit opening and then you're, you know, 2 points on the inside, and then you're just saying now the 2 points are on the outside. And the difference is you don't have all that extra light going through the open slit in the single impediment experiment. You have a bunch of peripheral light that has to essentially be bent to get to the center. But it still can get there. Alright. I haven't seen any video that represents the experiment with first using a single slit and then using the same size impediment. That might be there, but yeah, it's always nobody there. Yes, there's no good videos on the slit experiments. Period. You could just say no complete, go-to source where you just say this is the place to go because they're doing it all right. There's no such video. What is the result? Can they control the laser beam width to see the difference when the beam width is greater or less than the slit width? Obviously it can't be less than, or you'll get nothing. So technically, right? So now we're really just talking about the visible photons versus the ones you don't see. I mean, obviously the periphery ones are they're there, but you don't obviously know they're there. It would be interesting to see. I have done only the right quarter of the circle. Yeah, well, that's sort of irrelevant. That's all you need. I mean, you only need one side, and just say the other side is just a complete duplicate. I suppose the other side we will do the same thing, but the vector b as the radius. Yes, you would change which one gets to be the source that has the consistent L, or like I said, you just measure the path length difference based on how much shorter it is rather than how much longer it is. So it means that we shift the calculation slit width D amount to the left. So again, the easier way to do it is you're just measuring the distance, the difference between the two lines. So now you're just saying shorter is the same as longer, as long as it's a wavelength or half a wavelength, shorter or longer. This really is different math compared to the other versions I made while keeping vector A as a pedal point. Okay, it will affect the pattern and the node distance variations in the center of the screen. It will give more complex variations, and it might be possible to see those effects with some specific settings for D, L, and W. Tiny amounts of difference. I mean, even in this formula, right, for the triangle, it seems kind of unintuitive in the sense that this line and this line are essentially being combined into one line, right? I mean, L squared and D squared, you're just taking these two lines and making them into one in a sense. And likewise when you just multiply them. So in a sense, you could argue that any tiny change in L is the same as a tiny change in D, which is kind of unintuitive because you're saying, well, if I'm changing the wavelength here, but this one's in the right direction is the catch. This one's moving in a direction that's going to be certainly making this line longer. This one's moving in a direction that doesn't make the line that much longer. So, it gets a little complicated. I guess that's what the cosine takes care of. But I have to admit, I don't, just looking at it intuitively, you say, that can't be right, because then I could just move L a tiny bit longer further away, and I'm going to get a different answer. But now technically you're going to get a very similar answer, because the L line and, these are such tiny angles, the L line and the unknown hypotenuse are running almost parallel. Okay. I guess for further study, I should now have a pretty good understanding of all three methods and geometry related to them. I guess for further study and explanations related to GeoGebra, whatever, construction, I need to just make a video and people might comment if there is something I missed and got wrong. Yeah, well, the part I would get to is how the different analyses are making this triangle, because obviously, like I said, the parallel line theory is doing something different than this. So it's saying it ends up with the same result as this, but I'm just saying, isn't this the explicit truth? The only way you can say this is sitting here, a point, a little speck of dust in space. the fact is these two lines exist, and these two lines are going to decide whether there's a photon or not, right? I mean, if there's a full wavelength of difference, then there's going to be a photon that hits here. And if there's not, there's going to be no photon that hits here. So that's the absolute truth, is we're just comparing two lines. And I just don't understand how, them comparing them as parallel lines and then guessing what the next node would be, essentially. That is different math. Alright, anyway. I mean, that's the way I'm interpreting it. Huh. Why is it only showing the two comments? Oh, I guess I did that somehow. I got x function reduced to this from 2lnw plus n squared w squared. Alright, so that seems like that's divided by 2d. So again, the d distance, I think, is only half in his version. So 2d is actually 1d. So that's different than mine in terms of there's no cosine in it, obviously. And what else is different? Well, I don't know. Is also L and W plus. Yeah, where's the wavelength? Oh yeah, I'm just going with the difference in the line. So the hypotenuse. So somehow. Oh yeah, the wavelength will come in when you're trying to compare how the two lines have to be a wavelength different. Okay. So that's the only place the wavelength is relevant in my math, is when you're making the comparison. Is it a full wavelength or a half wavelength? Is it closer to being a half wavelength or closer to being a full wavelength in difference in length of the lines? Alright, numerator divided. Okay, so we can see that the DraftScience method has this extra term in the numerator. Divided by compared to the usual. Okay, well, whatever. I'm just saying this shouldn't be this complicated. I'm just saying, can we agree that I can erase everything, right? And we can just say this is all there is. There's just this. Okay, there's 2 points in space, and there's 2 lines. Well, I'll just erase it all and just redraw it, right? And that's all there is. So we should agree on what we're attempting to calculate. Is there's a point in space, and we have 2 sources, and this is all we need to know, right? Is that we're just comparing the length of this line to this line, and that's it. There shouldn't be any dispute that this. Funny how the camera must do that. Let's see, I can fix that. No, that doesn't fix it at all. Funny how it looks. This looks like a straight line to me. Oh yeah, well that point was way off. Never mind. Alright, so we just got that distance from 2 point sources, and we're just going to compare this line to this line, and if it's, a full wavelength, then we know we have photons at that location, and if it's a half wavelength, then we know it's no photon. Isn't that all there is? So why is this complicated? What's the best way to calculate how long this line is compared to this line? Is that the dispute? Because yeah, it's just we should be able to agree that this is all there is. This is happening in space, and for every point you draw a different triangle. But we should agree on the triangle. So this shouldn't be that complicated. That's all I'm saying. I mean, we should all be able to agree that that's what we're doing. We're just trying to figure out which one of those, how long those lines are compared to each other. All right. So anyway, yeah. So it's maybe I'll just leave it at that, and until we have something more to add in terms of making some real comparisons to maybe finding a piece of data where somebody has done which has to be done kind of carefully. I mean, we're talking about very tiny little differences in distances. You know, you get them a little bit off, you get a completely different pattern. I mean, it just takes a little tiny bit of movement in that slit width, and you get a completely different pattern. Well, completely, yeah, it's in completely different places. So it doesn't take much change to make a lot of change in the pattern. So we need somebody who can do careful measurements, do the experiment, and then we'll just compare, you know. But we can, I mean, right now we should be able to compare and just say, why are we getting different numbers for the length of these two lines? Because technically we shouldn't be, it shouldn't be possible to get a different number for the length of these lines. It shouldn't be possible because it's so simple. What interference is defined as is so simple. You know, obviously I'm not calling it interference, but it's not, yeah. Well, anyway. Let's see where it goes. Blah, 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 blah. But yes, thank you to both persons for... So, to me, I just want that simple math done and then just make the... Just put it on an arc and just show it as, you know... It's okay to have the point where you have the maximum in phase and then you have the maximum out of phase, but the truth is those numbers are gradual, and that would be sort of interesting also, is to see there should be a perfect consistency between the out of phase number and the in phase number, right? I mean, a full wavelength and some portion of a wavelength, we shouldn't have the same deal where it gets gradually one or the other. It should just be you know, it's 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, you know, and then cycles through again. Alright, so anyway, kind of a mess of a video, but I think the point is somewhere we have to agree on something. And I just think everybody should agree that the math, no matter how they're doing it, is trying to do just this simple thing of comparing two lines that have to be going to one point somewhere in space. Whether you put it on a flat surface or not, it's still one place in space. The two lines have to be coming to, and they have to be leaving from the same locations. Yeah, that seems like there should be agreement on that. But anyway, so yeah, I guess I'll call it a video. Alright, so till the next time and such, this has been a DraftScience sort of video presentation. Mostly. Kind of.